Hello, my name is Peter Kim, and this is my Physics 2211 Lab 3 Black Hole and Orbits presentation. A quick overview of what we're going to go over this video will be first the lab objective, the physics concepts that are necessary before doing the lab, the coding as well for GlowScript, lab results, as well as lab questions at the end. Our main objective for part 1 was to find the mass of a black hole using a computational model, as well as in part 2 was to find the initial velocity for a spaceship to orbit both the moon and the planet without crashing. And both were supposed to be made the computational model using the tool GlowScript. Now, some physics concepts before that are necessary to know before completing the lab are Newton's second law, which is F net equals delta P over delta T, or a net force of an object is its change in momentum over the change in time. And we need to know the velocity update as well as the position update, and that Fg equals the force of gravity is equal to negative G times m1 times m2 over r squared times r hat. Now for the code, part 1 is on the left as well as part 2 on the right. In part 1, we were supposed to change many of the formulas as well as to derive F net equals dpt, and then to update the star position using the MBH. In part 2, we were supposed to update supposed to find the position of the planet to the moon or the ship to the moon, and then find the force net of the planet on the moon or the planet to the moon or on the ship, and then thus to find the F net on ship, which would be able to help us update the velocity update for the moon as well as the ship and the position of the moon and the position of the ship. Now our lab results. The top here is from part 1 and part 2 was the bottom one. Part 1, the mass of the black hole that we computed was 1.35313 times 10 to the 34th power grams. Part 2, kilograms. Part 2, it turns out the initial velocity that we need for our computational model was negative 21,000 and on the x and 34,000 positive on the y, while 0 on the z-axis, meters over seconds. This is what the outcome of our second part 2 was. Without our planet was able to, and planet and spaceship were able to rotate or orbit around the planet without any interferences or crashes while creating a figure 8. Now, what does this mean? In part 1, in your analysis, you should discuss how the net force and its parallel and perpendicular components are different from the rate of change of momentum and its parallel and perpendicular components. Now, both are mathematically the same. However, the rate of change of momentum is easier to calculate as all we need is the system's change in velocity. But the net force requires us to take into account of every factor exerting a force onto the system, which can be lengthy, but still would give us the same answer as the rate of change of momentum. Now, what if all we need to do was to find all individual forces acting upon each other in the system, in the entire system. Now, some objects may be more dominant and be strong, have more of a force because of their mass, such as a black hole. Now, some errors that may occur from doing the lab could be possible errors such as rounding error, where not all values are entirely in its true form, as we do need to round certain numbers to get during our derivation for the formulas. Thank you.